Welcome everyone to the last seminar of the term of the Oxford Polar Forum. And today, as Paul said, he's going to be in charge of introducing our guests, Jane Francis, director of the British Antarctic Survey. So I'm not gonna go on further, and I give the word to Paul and then to Jane.
Thanks, Mark. So as the chat at the beginning of this has shown, Jane doesn't need much introduction to many people in this audience. But for those of you who don't know her, she's director of the British Antarctic Survey, job she's done since 2013. And in 2017, she was appointed as a Dame Commander of the Order of St. Michael and St. George for services to polar science, UK polar science, and to diplomacy. And I know Jane best because of her principal research interests in palaeoclimatology and palaeobotany. As some of you will know, she worked for many years as a lecturer and then a professor at the University of Leeds before she became the Dean of the Faculty of Environment. And Jane's research over the years has specialised in the study of fossil plants, particularly wood, and how you can use those to interpret climate, but also biodiversity at the poles. She's currently working on past climate change during icehouse and greenhouse periods, particularly in the polar regions, of course, and particularly because they're the most sensitive areas to climate change, as we know. As a poacher turned gamekeeper, or perhaps the other way around, she became Chancellor of the University of Leeds, her old stomping ground, in 2018. And tonight, Jane's going to talk to us about future science in the polar regions, your role at the ends of the Earth. It's all yours, Jane.
Great, thank you. So I was asked to talk about future science in the polar regions, but what I'm actually going to do is I'm going to talk about some of the big science that's going on at the moment. And also I'm going to show you some new facilities in Antarctica that I would like to recruit you to. So this is a recruitment campaign, if more than a bit of science. So I'm going to start off with this picture here because this is a picture of Ny-Ålesund. So Henry's in the audience, and so I won't talk about the Arctic because Henry covered that in the last talk you had, and you can watch his recording. This is actually a webcam image across the field, across Ny-Ålesund Research Village. Now I don't know what you managed to get to, Henry, but the UK has a small station near where the arrow is printing, and Henry is head of the Arctic office, is sort of in charge of people going there. So if you would like to go to the Arctic office, to go to Ny-Ålesund, to the UK station there, please do contact Henry. It's a fantastic place. It's easy to get to. You can get to Ny-Ålesund more or less in a day if you're lucky, and in the summer it's really beautiful on the tundra, so you can do tundra research, you can work in the field, there's glaciers there, and it's the place in the Arctic that really is warming the most. And you can, I mean, even the years that we've been going up there each summer, I take visitors up there with Henry, and we've seen changes year on year. So it is a fantastic place to do research. It's a really good place to train students and take student projects as well. So it's accessible, and apart from the polar bears, it's relatively safe. So do contact Henry and he'll teach you how to shoot. So let's go to Antarctica. So here's a beautiful satellite image of Antarctica. Most of you may know that it's 4 kilometers thick of ice in places. And I think the big change in Antarctic science over the last few years is that the science isn't just about what's happening in Antarctica. It's about how what's happening in Antarctica affects the whole planet. And whenever we do research these days, I think it's about that's the key impact at the end. What is it that is happening to Antarctica that's affecting the rest of the world? And the biggest driver is really the melting of the ice sheets on land and the rising global sea level. And you will always see this number, about 50 meters, 55 meters of sea level rise across the globe if all the ice on Antarctica melted. And if all the ice on Antarctica melted, that would mean probably all the ice on Greenland and the rest of the world would have gone too. So, I mean, most countries would would be carved in their area of extent if that happened. So that's the big question in Antarctica at the moment that I'm going to really focus on. How is climate change affecting the Antarctic ice sheets? And it involves also the ice shelves around Antarctica. So this is where the ice sheets then come down from the land and they reach the sea, and then they float out over the sea. And I'm going to show you some research, which really is the sort of the big projects that are happening at the moment that are looking at the melting of these ice shelves. So this is one of my favorite pictures of Antarctica. This is a NASA image, and it's colored, false colored, to show you the ice streams in Antarctica. So they just happen to look like trees and plants. But so you see the things that look like trees there. Those are the ice streams or the glaciers that are flowing from the highland areas, especially in the center of Antarctica, down towards the purple areas, which are the ice shelves. So the ice streams are on land, and they carry most of the fresh water. And then the ice shelves are areas where the ice then floats on the sea. And those ice shelves are really important because they act as buffers or doorstops or buttresses, people call them, to stop the ice on land flowing out to sea. And of course, the ice shelves don't contribute to global sea level, but the ice streams will do once they get to the ocean. And the really big question is that people are looking at is the ocean around Antarctica, particularly this side, which is sort of facing you by the Antarctic Peninsula, that finger-like portion of Antarctica that's pointing up to South America, is that warming ocean melting the ice shelves from below? And if they are, then if the ice shelves disappear, then all that ice in the form of the ice streams will really flow much faster into the oceans, and then you'll get global sea level rise. Now, you can see there's 3 black stars on here. There's 2 here on this ice sheaf, the Ronnie ice shelf, and you can see one down here. This is the Thwaites ice shelf, and this is particularly important. I'm going to talk about this later, but you can see that there's an entrance, so the ice shelf then goes in through like that, and the area which the ice is flowing is this area here. So let's go and have a look at some of that. So a lot of the big projects that go on in Antarctica today are big collaborative projects. They're big international projects now. There's, gone are the days when, one man and his dogs will go out on a sled, or one man and one field assistant and their skidoo. I don't think anybody does that anymore. Most of the big deep field science is big science, big collaborative science. Antarctic people like to put their flags up, all the time in your camp. But you'll see a lot of kit around these big projects. A lot of them are international collaboration to share logistics and funding. So here's one of them. Let me see if I can get rid of this picture. That's better. Again, is the ice sheet responding to warmer climate? This was a project that actually is just about finished in terms of its field work. And this was about a big group US-UK collaboration drilling through an ice sheet to see what was happening at the bed of the ice sheet in contact with the rock below. So this was a massive project that took about 6 months in the field for a couple of years. And you can see there all these gadgets they took with them. And this was to melt water, to have these big bulging ponds here of hot water. So they dissolved their way down through. No, I can't do anything. Can you hear me still?
Yeah, we can hear you.
Yes, we can hear you, and we see the screen as well.
Yeah, but it's stopped now. I'm going to, oh, here we go. It's going again. Let's see. Anyway, I'll keep going. So what they did was they used hot water to melt a hole right through to the base of the ice sheet. So this is a fantastic operation because you have to keep hot water going down through that hole 24 hours a day for months and months on end, because otherwise the hole will seal up. And then they put down instrumentation, which is still there at the base of the ice sheet, recording the relationship of the ice sheet and the ice and the rock below, because that's really one of the major controls on what happens. So that was the deepest 2-kilometre hole that's ever been drilled in an ice sheet. The other big drilling for ice sheet history, and again you see that's a big camp. So there's a chap there, Rob Mulvaney, with his ice core machine drilling for ice core history. They're here on the right hand side. You can see a bit of an ice core here, which they then pack up in these big polystyrene boxes and send back to the lab. So that what they're looking at is what has happened to the ice sheet over the last hundreds of thousands of years. And I'm not sure whether all of you in the audience know about this. I could be telling you just your grandmother how to suck eggs, or you will probably know this, but anyway, I'll go through it again. So the really key thing about looking at past ice sheets is and ice coring are taking these thin slivers of ice, which they can date quite accurately, and then looking at these bubbles that you see in the ice. So these bubbles, this is really quite remarkable, because in those bubbles, in these bubbles, there are the remains of the atmosphere millions of years ago, hundreds of thousands of years ago. And this is actually the real atmosphere from all that time ago. So this isn't a proxy, this is the actual atmosphere that got trapped between snow crystals and then frozen into these bubbles. And so they bring these ice cores back to the lab, they store them in Asda's food supermarket, big freezers first, and then bring them over to Bass, chop them up into slices, and then they take them into our labs where they crush and break down the ice, capture the gases that come out of these air bubbles, and then they analyze them. Now, you may be familiar with this. I put this in because I think this is the most famous graph that anybody's produced from ice cores. And when I show people around Bass and we talk about climate change, it's surprising, but this graph really captivates everybody, including politicians. And this is the one thing they take a picture of. So it's a really powerful way of explaining where we are today. So if you've not seen this before, this is Vostok or Epica ice core data. Here's 0 here for present day. We go back in time 800,000 years, and then you can see 2 curves here with zigzags. This is the temperature from oxygen isotopes, and this is the CO2 concentration in the past. And these cycles are the orbital cycles that govern waxing and waning of ice sheets once you're in a big ice age. The really key thing to take away from this is you can see that from the past 800,000 years, when we've been in an ice age, you can see that the concentration of CO2 has never been above 300 parts per million. But look where we are now. We're way up here. Look, we're about 410 parts per million today, I checked. And so we're way, way, way above the sort of the carbon dioxide ice age. So we are way, way above the stability of where we used to be when the ice used to come and go. So we're in a different world. And the thing is, the Earth is trying to catch up and become a 400 parts per million world today. And even if we stop putting CO2 in the atmosphere today, it's still going to take a long time, if ever, to get back to there. We just need to find some stability, I think, at 400 parts per million. So a big project that is working on what's happening to climate change in Antarctica today, and they will take ice cores in this project, is, you may have heard about this, this is the Thwaites Glacier project, the largest field program in Antarctica. And here you can see it just was an epic trying to get everything in the field. So here you can see 2 ships. So here's HMS Protector, the Navy ship, and the Ernest Shackleton, which was a Bass ship, now sold to the Italians and working for Italy in the Antarctic. But they spent many trips through the ice, delivering fuel and cargo. So ships can carry can do joint work on land projects. Ships don't just do marine science, they do land projects as well, particularly delivering equipment to the ice margin. You'll see why that's relevant later. And then here is a picture of another way that we transport equipment now in Bass, particularly because it's a bit cheaper, and that's by tractor traverse. So you can see here across the ice fields of Antarctica, these groups of people set off for months on end, and you can see they are at the front of their tractor train. They've got what's a piston bully, kind of snowplow, and then there's this black thing is a container which actually contains an IKEA kitchen and a living room area, and then here is all camping gear and science gear and things like that. And you can see that it's being dragged along on a rubber mat. That's all it is underneath there. There's no trailer, there's just a rubber mat. And these two are just pulling, again, bladders of fuel. So rather than putting and carrying fuel in bladders, in drums, we carry them in bladders, and they're just being carried along on these rubber mats. It's much cheaper and it's much easier. And so these, at the beginning of a season, these tractor trains trundle across Antarctica to the field sites where they're needed for these big projects. And if you don't go and do that, so this is a picture of some of the kit that was left for Thwaites project, which is still ongoing. And unfortunately, because of COVID, there's no science in Antarctica this year. And probably this is what some of the kit looks like. And this that was left there. And this is probably buried at least sort of 10 to 12 feet above the snow surface last season. And unfortunately, a lot of very people are going to have to go and dig this out before we can resume the science. So here's the Thwaites Glacier project. Here's the Thwaites Glacier, and then coming down to the ice shelf. So there's already been some ship expeditions here. So the ship a couple of years ago put in moorings, and they sent off these AUVs to go for the first time to take a look underneath an ice shelf here. So it's really never been done properly before. And what they're trying to do is track the passage of warming water right underneath this ice shelf, underneath to the place where the grounding zone is, where the glacier actually meets the ground. And the real worry is that the warm water is going to melt out this point here, and the warm water will then escape right into here. And the Thwaites Glacier is particularly critical because if it carries on going inland, it will melt the heart out of the West Antarctic ice sheet, and it will start melting this glacier from below. And then the whole ice sheet might collapse. But you can see here, so there were expeditions on a ship, there were expeditions on the ice shelf. On the ice shelf, you can see here, there's camps here. There were satellite images taken. There's a tractor train here carrying equipment to do radar and gravity across the ice shelf. There are moorings, and there were people working on the mountains either side to look at the age of the ice sheet. There were twin otters working, and lots of camps across both sheets. There's still a couple of years to go, and so there's still much more science to do. But it's a very, very intensive, very expensive, very logistic heavy operation, but really critical science. I just want to mention another really key area of research, I think, which is really important for the future, and that's looking at the oceans. So the Southern Ocean around Antarctica is very special because it's the only ocean that goes all the way around a single continent, and it is the source of that cold bottom water from the melting of the ice sheets in Antarctica. And you can see here it's part of that global network of ocean currents that flow from Antarctica's cold water, and then it mixes with warmer water as it rises and forms this ocean conveyor network that goes right from one pole to another. And it's really these currents that transfer all the heat around the globe. But it is quite important, and the Southern Ocean is very poorly studied because it's remote, and if you've been on, you'll know it's horrible. It's stormy, and it really is a nightmare ocean to work on. You have to have a very strong stomach, but it is really critical because it's also very deep, and it's formed here. You can see it's a continuous ocean. There's a lot of these gyres in the current around Antarctica, but they're taking down heat and carbon dioxide into the deep ocean. And so it's already been some work has been ongoing, which shows that it's taken in about 36 degrees centigrade worth of heat that we've caused recently, and it is absorbing a huge amount of carbon dioxide that we're producing. So this is really buffering the anthropogenic CO2 at the moment. And the real question is, you know, how much longer can this carry on? How much more can the oceans take? And what happens, if you like, if it's full up of carbon dioxide, if it can't take any more and it can't take any more heat, what really is going to happen to our climate? So there's loads more work to be done in the ocean currently. So this is where I get to show you all our new toys, the UK's new toys on this ship. So, and to recruit you to come and think of big, ambitious projects to do some science on this ship. So here's the Sir David Attenborough. We call it the SDA, if I refer to that, unfortunately. But it is a massive ship, and it's currently sailing. It's come out of the shipyard from Camel Laird in Liverpool recently. It's now belongs to NERC and operated to UKRI, NERC, and operated by BAS for the whole of the UK, support any kind of science which is funded by a UK research council. It's currently at the moment sitting in Holyhead in Wales because the port is deep enough, and it's sort of been out and about in the Irish Sea just to test things like the lifeboats and a few of its properties. But it will be there just testing. Everything has got to be tested, absolutely everything, you know, lifeboats, dishwashers, all the cranes and the winches and everything, until it can go off for proper service. So it will go to the Arctic in about January and find some ice in the Arctic to test the ice breaking capabilities. And then it will come back in about October and then go to Antarctica. Can I just check that you're all there? Because I can't see you at the moment.
We're here.
We're here.
Okay, right, that's good. I can't see any, so we'll keep going. So it is a big ship. So here's a cross section of the ship. We're building a website in BAS to give you more information, and I'll put a link to that, but it's in progress. There are 11 decks on this ship. I can't remember how many there are on the JCR, but it's just a few. And it's enormous, this ship. So there is a lift from the top to the bottom. And several of these bottom layers are scientific labs. And then there's accommodation in here. And there's other bits, so I'm going to show you around the ship. So I just want to point out one place, and that's down here where there's a propeller. So this ship has dynamic positioning, which means, you know, it's got propellers that can mean it can move on a pinhead almost. So here's the propeller. I love this picture because look at it. This shows you the scale of this ship. This is the base of the ship and the propellers underneath it. So I'll go back, look, there, it's down here. That's the scale down there. So this is an absolutely ginormous ship. There's loads of numbers here, 120 meters long, 20, you know, this won't mean anything to you. It's 2,000, it's the weight of 2,000 elephants. That's what bit I remember. It can go 19,000 nautical miles full of fuel. The most important thing is that it is big, so it can take up to 60 scientists to go, whereas the JCR just can take a handful. It's polar class 5, so it means that it can break 1 meter thick ice, so seasonal ice at 3 knots. So it's not going to go through thick multi-year ice, but it can go into ice. It's got dynamic positioning, so that means it's got lots of different, the propellers can operate separately and really pin down the positioning. It's particularly designed as proper science ship so that it's very quiet when it needs to do, you know, the engine is quiet. There's a lot of controversy about the noise with marine animals and marine organisms, but it's quiet, but it's also very calm, so we can do a lot of sonar and things like that. 11 decks, there are 15 scientific laboratories on there. I think we can get something like 80 containers on there because everything will be containerized, and there's space for helicopters. So the one thing that's really novel on this ship that UK hasn't had before, which is really good, is that there's a moon pool in the center of the ship. So basically there's a hole. Can you see this hole here in the center of the ship? It's about 4 meters times 4 meters, and it can open up at the bottom, and you can get into the ocean down here. And there's a doorway to stop it coming up, and you can also close it up at the top here. So this isn't quite finished here, so it's not the end of the this isn't finished. But what you can do is you can launch a lot of scientific equipment from the ship down through the moon pool. So it means that when the ship is in ice and you have equipment that would normally go over the side of the ship, which obviously you can't put in the sea if there's ice on the sea, you can actually launch it down through the moon pool, which is really means that this ship can go into ice and work in ice, which is great. So for example, I'm not going to show you everything because we had we revealed the science in a workshop last week, and there's something like 100 slides of different scientific kit on this ship. So I'm just going to go a quick romp through some of the scientific capabilities. But there's going to be a lot of autonomous vehicles on here, because what we want to do is make this ship as green as possible. So rather than the ship moving around a lot and using fuel, which a lot of modern ships do, the ship will stay put, and we'll send out AUVs to collect the data. In particular, ROVs. So here on this back deck here, there's an office which will drive the ROVs. So there it is there. And that will be launched there, can be launched through the moon pool. And then its results will be transmitted back onto screens. So there's something like 150 screens throughout the ship, so that wherever you are, you can work on the data and transmit the video that's of the bottom of the seafloor into all these different labs. There's a science workboat, and we don't have one of these currently on the ship, so it does mean we can do coastal work, we can do shallow water work, and there's quite a lot of kit on the workboat. So there's 2 small boats, Erebus and Terra, but Erebus is the science boat with science kit on it. The ship can take 2 helicopters. We don't have helicopters on it because they're very expensive, and you need, you know, engineers to run them, and it just would be far too expensive. But if any grants ever needed helicopters to support their marine or terrestrial work, then they would be, you'd put that on the grant, and then NERC would pay. So there's helideck, and that will be used, if there's no helicopters on it, it will be used to launch drones. So we will be doing a lot of drone work, of drones of different kinds on this ship, again, to save fuel and to be much greener. And then the hangar will be used for all different kinds of experiments when there's space. And this strange picture is the bottom of the ship. So the bottom of the ship is just absolutely packed full of equipment, sonar equipment and echo sounders and things like this. So we will definitely not be going anywhere that's particularly rocky or muddy, but it will be able to do a huge amount of imaging underwater. So it will be particularly be doing a lot of work on swarms of zooplankton, krill and fish in the Southern Ocean. We do that at the moment for CAMLAR, or conservation of Antarctic marine living resources, but with much, much cruder equipment than this. And here's another one, there's sonar as well, really high-tech sonar that will give you views of everything from the fish again, and anything else that's on the bottom of the seafloor. They'll also be able to take all kinds of what's I think is fairly traditional sampling equipment for biology, marine biology. So these things called bongo nets, plankton nets, and different kinds of water samplers that NERC has a big store of in the marine equipment in NOC. And so these will also be fitted on this ship. And here, this is on another ship, but this was what it will look like. So for you geologists, there are seismic profiling systems of several kinds that can be launched from the ship, and a lot of these streamers to do seismic collection from the ship as well. And this is a new facility as well, Stuart. This is a corer, piston corer, which is 40 meters long. So you can actually collect a fairly good record, a rock record, some good rock cores, sediment cores, or semi-consolidated cores of 40 meters long through here to get the sort of paleo record. So this is really fantastic. If you get the right site, a 40-meter core is really as good as you can get right back to the Cretaceous, as the Germans did recently. So this will be a great asset to this ship for geologists. For biologists, there's whole labs full of aquaria, so a different temperature. They'll be able to do experimental work on the ship. So at the moment, what happens is people collect marine biology samples from Antarctica, they work on them in Rothera, they put them on the travel aquarium on the JCR, and then they come back to Bast into the aquarium to be worked on and then sent to universities. But here you'll be able to do quite a lot of research actually on the ship at the time, which is fantastic. And these are the kind of labs. This is the wet lab, and it's almost as if somebody went shopping in a scientific instrument store and just put everything in their basket. The kit on these in the ship is quite staggering. I've seen it listed on paper, but when somebody gave a talk last week and showed us what it was like, it is quite astounding. There's lots more that I'm not showing you. And even for people outside, so when they go around the sub-Antarctic islands, or you go into the Arctic and you want to do watching for whales and other marine creatures, there's even special areas which will keep you warm with wind shielding and these corridors where you can watch with windows to be able to do marine mammal watching. So everything's been thought of. It's quite amazing. And it's not bad on the ship either. So this is one of the berths, and there are space for 60 people. So some of them are double berths and some of them are single, but they're all pretty nice and all very small. And what you can't see in this cabin, where I am, where you're watching from, there's a ensuite shower and toilet, and then there's wardrobes and a small desk. And this is on the SDA. This is the kitchen, the galley, brand new, hasn't been used yet, but there are people on there now, crew, and apparently the food is extremely good, so spanking new. And this is the conference room. So this is a special table that's been made up and donated to the ship, which looks like the hull of a ship or a whale. This is a conference room with all the facilities for conferencing on the ship. And in the side, you can see on the left-hand side, these are offices for scientists and anybody who wants to work there. Rather than working in your cabin, you can come and work in this rather nice place here, which is all fitted out with Wi-Fi and everything that you possibly need to work properly. So it really is quite a spectacular ship. And what we're really after now is some really ambitious science ideas. So the ship has got 2 years of testing in the Arctic and testing in the Antarctic. The ship has to do both logistics, so it's got to supply all the stations in Antarctica, but there will be plenty of time for science as well. And the ship demands really big science projects. So it's not really going to go to sea with, you know, a NERC standard grant with 2 people who want to do something. It really needs to be full of a really big project, possibly international, sharing the funding, and with a really big, ambitious science ideas. And I think now is a good time to start thinking about it, because it will take about 5 years to think about what these science questions are, how to get your teams together, working with NERC to think about how this is going to work. NERC will then help work with partnerships and getting this going. And if there's some really good science and really good partnerships, I'm pretty sure that NERC will put money into special programs for this ship science, both Antarctic and the Arctic. So to some extent, this is really why it's great to talk to early career researchers, because by the time this ship really gets going, I'll be retired, Paul will be retired. And so this is, if you're sitting there as an early career researcher and you'd love to use this ship, this is your opportunity to get together, find some great ideas, and then push them forward for ship science of the future. So Sophie Fielding here, who works at Bass, and she's been on many cruises, and she knows this ship and others inside out. She's been helped with the planning. She's going to be our science contact. We're at the early stages at the moment of trying to understand what the ship can do and trying to get the community together. It doesn't have to be just NERC science. We also want artists and other research council people, engineers, to work on this ship too. So it's really open call really about for ideas. So if you've got ideas and you want to be considered for any kind of future workshops or future meetings to talk about this, please contact Sophie and let her know that you're interested. There's some other things as well. If you're not into ships, if like me, you get terribly seasick, so I'm not going to be going very far on that ship. We have a new building in Rothera. So Rothera is our main station, our main hub in Antarctica, on the Antarctic Peninsula. And currently it's a lot of old buildings that were built in the 80s and are really not fit for purpose. So they're going to be knocked down, and this building will be built instead. So we have, there's a bit of a delay this season because of COVID, but next year this skeleton will go up. And you can see this is going to be a brand new building for science support that will take the place of about 8 other buildings that are going to be knocked down. And in this building, there will be everything from science support areas, work areas, there's the storage areas if you go out in the field, to the garage, to the generators, to the hospital, to social areas. This is where scientists will go to get supported for their science. So for example, this is a mock-up of the offices. So if you're there and you're in transit and you want to do some work, this is where you'll go. And I'm willing to stake my life on the fact that there will not be bright pink cupboards there in the end, because I can't see anybody tolerating that. But it is a pretty smart place to work. The facilities will be much better than they are now. And then there will be breakout areas. So this sort of where you can get a cup of coffee to work while you're in this building. There's another building which has got the canteen and a kitchen, but this is especially for as you to a break when you're having your science. There's a gym, there's a music room, there's this is storage areas. So when you come from wherever, from UK, and you have all your kit, you'll be given one of these bays, these numbered bays, and that's where you can put all your field kit. You can prepare all your field kit. It takes about a week or so, and then from here, then you'll go out into the field. And then when you come back again, this is where you'll put all your samples before they're shipped out. So we just don't have this kind of space at the moment. So this is absolutely fantastic. And Discovery Building is going to support all Antarctic science. So everything from anything that anybody that works in the field, anybody that works on animals, plants, terrestrial science, everything. So we have this fantastic array now of new facilities. In the future, we will have a new aircraft to replace our old aging aircraft, and a new accommodation to replace some of the old accommodation, which is really tired now. I've got there, I'll leave this with you, but the BAS video, Extreme Antarctica, which you can watch to look at some of the other kind of science that we do, and some of the reasons for doing it. And I'll just end on here because I haven't talked about animals, but I mean, there's a whole range of science, terrestrial science on the sub-Antarctic islands like South Georgia and the Antarctic Peninsula that people are working on. So again, the ship can take you to study krill particularly, and fish, and it can take you to the stations to study albatross and the penguins and the seals. It can take you, the small boats can take you out to study the whales, which are coming back to South Georgia. And it can also take you to remote islands to study some of the terrestrial plants there. So things are looking pretty good for the future of Antarctic science. And we need some of you guys to be the ones that put the science ideas together to get funding. And thank you very much. I'll finish there.
Thanks very much, Jane. An excellent overview.
I'll stop sharing. Yeah, there you go.
That's great. I'll just get the chat back. So a few questions coming in, and I'm sure there'll be others as we carry on. Someone asked, what are the examples of the labs on the Sir David Attenborough, or are they multi-purpose labs?
Oh, there's all sorts of things. So there's atmospheric labs. So if you want, if you're doing atmospherics, there's all kit all over the ship, but there's particularly clean labs. So if you want to work in enclosed clean spaces, if you're doing very detailed chemical measurements, there are particularly clean labs. There are places where you can measure certain types of metals, trace metals, that you have to be extremely careful about what's in there. So all the equipment is non-contaminable, samples like that. You name it, there's a lab there. I mean, it's staggering. I think you can do practically everything on this ship. And the other thing is, there are set labs, like I showed you the wet lab, but a lot of the labs will be in containers as well, so that you can change the labs around. So if you want something special, you can order a container and then build your lab inside the container. And in fact, the way that this ship will operate is, I don't know if you've seen the JCR, the James Clark Ross, being unloaded at the moment, but it's pretty much almost like the old sailors, hand to hand unloading boxes. But everything in the future is going to be in containers. So it will be packed in containers in the UK and just sort of winched onto the ship. And then all those big cranes on the ship, once we get to, say, Rothera, instead of taking a week to unload the ship, it will just take one day. That's it, And so everything, the logistics must go much faster to be able to cope with logistics and science.
It's a hugely impressive project, I must say. You did show Stuart the piston core a bit. He also asked in the chat whether the moon pool allows for the deployment of drilling and coring rigs.
I don't know specifically, Stuart, but I mean, it's just a big hole. So I think it depends what attachments you need at the top. So I think there's a lot of winches on there. So I guess it depends on whether the winch can work. I don't know exactly how that will work. Yeah.
Because I was wondering about so the BGS has sort of a drilling rig.
Yes.
So thinking about some of the sort of activities of ECORD in the past, where they deployed mobile rigs onto ships with moon pools. Yep.
Well, there was a cruise not so long ago, wasn't there? The MEBO cruise for the Germans that got back to that Cretaceous sediments,
Yeah.
And
that's
I think
that's the sea floor rig though.
Yeah.
You could just drop over the side effectively.
Yeah. So I think that's what the BGS's one is, isn't it? So they can do something like that. Yeah.
Yeah, I think they have both, but yeah. Cool.
But I think, you know, there's huge potential with that big piston core. I think it'll be very exciting to use that.
Mark, yes.
Yes, thanks, Jane. I have a couple of questions about the route. So you said that in about 5 years it's going to be fully operational. And the question is, because it has to provide the stations in Antarctica, how often do you think it will be in the Arctic? And then the other one is, how are the routes decided and how much time in advance?
Okay, so well, let's look at the Arctic. So the Arctic, the ship has to go to the Antarctic every year because it has to supply the stations in the Antarctic. So unless something really radical happens and there's such a big need to be in the Arctic in the winter, so it can't go, you know, we have to hire something else, but I don't think that's likely to happen. So it will have to go to the Antarctic stations to supply them. And then to some extent, what happens in the program will depend on the science that is planned and funded. So if, for example, there is a really amazing, ambitious science program that is international and that NERC funds, you can imagine there might be two international ships joining with the SDA, and we have a big cruise, and maybe they need a lot of the season. Then if there's sort of a 5-year planning window, that's what we're thinking about, 5-year planning window, then the logistics people can plan that is the year they're not going to take a lot of fuel down, then they're not going to spend a lot of time at the stations, and they have to shift that to other years. The Arctic is very different because the Arctic is, Arctic science has to be funded on grants. So BAS isn't, so it doesn't, we don't have the remit to work in the Arctic, and we don't have the money to work in the Arctic either, just the Antarctic. So if anybody wants to go on an Arctic cruise, then that's a science proposal that NERC funds, or anybody else funds really. And then the ship will go there, that's fine, it will go there in the summer, in the northern summer. So the only thing that the ship has to do in the northern summer, it has to go to refit every year. So it'll have to have, you know, like going for its MOT in the garage, and it'll have to go and do that for a few weeks, but then it will be 60 days. It's on average, it works 2 months in the Arctic every summer. The interesting thing is, though, I think a lot of people want to go to places in the winter. So they want to go to the Antarctic winter, and last week they were talking about Antarctic winter and the Arctic winter, which is really quite exciting science. It will be challenging to go to the Antarctic in the winter, I can tell you, just from the logistic point of view and the ice point of view, but good for science, very exciting for science too.
Thanks, Jane. Any other questions?
So yes, I see Maria. Sorry, Jane. There was a Maria Dance had a question, but if you wanted to say something.
No, Maria goes first.
Hi, thanks for the talk. Linked to what you were just talking about, as any travel in the Arctic has to be funded through grants, do you have any idea of like how much the operational costs for the ship are for, say, I don't know, a month doing sort of standard work or sort of baseline, you know, because I have no idea how much, like, yeah, well, what is the scale of money that you would need from grants for this?
Well, if you wanted to go and work in the Arctic, let's say you put in a grant proposal, then you wouldn't really particularly have to worry about that, because the marine planning, there's a marine planning group in NERC, and they would tell you what the costs are. So you don't have to work it out yourself. They'll just tell you. And to some extent, if it's really expensive, they'll work out a way of doing it. I mean, NERC has had almost continuously now for several years, and Henry can tell me if it's how long it is, but several years they've had Arctic programs. So rather than doing one-offs, they've decided to have these really big programs that last 5 years with 5 seasons or something. And then you apply as part of that program. So you don't have to worry about the costs, because NERC has already paid for the ship to go there. But if you really want to know, it's staggeringly expensive to go on a ship I can't remember how much. I think I asked somebody how much it would take to fill up the fuel tank of the SDA, and it's like over £1 million. So your credit card would be a bit red hot if you tried to put that in at the petrol pump. Yeah. But the cost of running ships, any ship, is thousands of pounds, tens of thousands of pounds a day, even if you don't go anywhere. But if you need to do the science, you need to have a ship,
Thanks.
And therefore we need to use the ship.
Thanks very much. Any other questions?
But can I say the reason that this is a new ship, it's going to be, the planning horizons for it is 5 years. So in a way, it's a good opportunity for, early career researchers, for people to take the time to plan big programs. And what the community really needs to do is to get together and think of the big science questions and go for it. At the moment, there's nothing on the table for the ship, except probably one cruise that the centres will do because they have to do national capability, long-term monitoring. And so the ship is looking for, NERC is looking for really good ideas for marine and terrestrial science in Antarctica. So it's a fantastic opportunity now to think about some ideas. So what we need to do, what we're trying to do is and this will sort of work out through demand, is how can we get the community together to talk about how you can build groups. And I think NERC will help run some more workshops that you can go to, virtual workshops that you can go to contribute ideas and be part of a sort of continuous discussion about evolving science ideas. And then what I hope will happen is that there'll be enough ideas and excitement that NERC will decide that maybe in a couple of years, when we know that the ship can really function well, it will decide that there's going to be a program like the Thwaites program, probably with international partners. I hope with Germany, because they've got another good ship, the Polish Stern, so we could do a double season or something like that, and that we could go to Antarctica. It's all the science is discussed, the logistics are arranged, and then it's a case of NERC announcing that there's so many millions on the table in this program, and that what you have to do is get together in your groups and then apply for part of that funding and be part of that group. So I think the key thing is, and this is what I really is talking about today, is if you're really excited about this, to stay in touch and be a group to do that science on the ship. It's a fantastic opportunity right now to be involved right from the beginning and develop some really great science ideas.
Thanks very much, Jane. The gauntlet is laid down, but yeah. What a fantastic opportunity. We've come to the end of our hour, so it just remains to thank you very much for giving up some time in your exceedingly busy diary, Jane. And I look forward to meeting up and having a beer at some stage in the not too distant future. So thanks very much.
Lovely, thanks. Great to see you all. But if you want, I mean, I've put Sophie's email in the slides, and I think we can put them on the. I'll just double check, Mark, but I think we can put them on the recording up. And but anyway, I'll put the contact somewhere, and just contact Sophie. She's collecting all names and addresses and details of anybody who's really interested, so that when the next workshop comes up, your name will be on her list. That's really important. So stay in touch. SOF at BAS, Sophie Fielding.
Easy to remember.
Yes.
And Mark, remind us when the first meeting next term is.
Yes, well, first of all, thank you all for coming today, and especially to Jane for having agreed on the seminar. Next term, we try to organize termly seminar series starting in week 1. So week 1, Hillary term for the Oxford people, or winter term or spring term. I don't know how they would be called. In mid-January, we will start. It looks like next term we might be running a series on Arctic research in the Russian Arctic, but this is to be confirmed. If you are part of the mailing list, you will receive updates on that soon, as soon as we have it ready. So that would be more or less the plan for next term.
Great. Thanks very much, Jane, and thanks everyone, and see you next term. Thank you very much.
Bye.
Goodbye.
Bye.